Good day, everyone. I'm Mr. Jerome Tanglao under the supervision of Dr. Elmer P. Calaguas. And I am here today to present my thesis entitled Development and Validation of a Self-Learning Digital Module in Mathematics 9. One of the problems that our educators facing nowadays is finding various ways that will make the learning meaningful to their students. Philippine educational system is suffering from dearth of instructional materials needed in the teaching of the teachers so as to the usability of the materials given by the Department of Education. Um, Innovating instructional materials is one of the challenges of the teacher to capture the interest of their students in the lesson, especially in our field, which is mathematics. The outcome of this problem is evident in the mathematics performance of our students. This is revealed by the results of the studies and performance tests, such as the Program for International Students Assessment and National Achievement Test. The digital and teaching and learning. The use of technology in educational settings has the potential of increasing students' deep learning. Utilizing technology in schools provides innovative teaching and learning experiences for both teachers and learners, which enables them to adapt in unending societal changes. The effectiveness of modules as an instructional materials. Modules in general are illustrated as self-learning materials that can be used by the learner at their own rate, even without the supervision of the teacher. These modules teach our students to become independent learners, which will help them to develop meaningful learning and to be successful in the future. The digital intervention in education. The use of technology in our sector rapidly increases in the modern day era. Several studies has proven that using this digital technology in teaching, strategies, and instructional materials, it generally improves the students' achievement in various subjects, especially in mathematics. The establishment of learning management system, or what we call LMS, it serves as a virtual extension of the classroom for both students and teachers. This was found to be generally accepted and effective in various studies. The pandemic we are experiencing today made a huge impact in our daily lives, especially in our educational sector. Face-to-face instruction that we got used to is quite impossible at the moment due to the danger of being infected in the disease. With the widespread of virtual technology, online instruction is gaining an attention and became trend as an alternative through traditional classroom setup, which turns into our new normal. Due to this pandemic, our routines were hampered and we need to adjust our educational system. In this slide, I, the researcher, who is also a grade 9 mathematics teacher, I'm inspired to develop and validate this module, which is called Self-Learning Digital Module, or what you call SLDM in Mathematics 9. Let's proceed to the theoretical framework. I used two theories in conducting my research. According to the constructivist theory, learners are critical thinkers. They are motivated and independent and are actively engaged in the process of meaning-making and knowledge construction, rather than passively receiving information. Then another theory from Benjamin Bloom, which is what you call Bloom's learning theory in relation to academic achievement. Bloom identified three interdependent variables central to the theory of learning: the extent to which the student has already learned the basic skills necessary for the task. Second, the extent to which the instruction is appropriate. Third, the extent of motivation to engage in the task. Thus, within the theories mentioned above, independent learning and constructing new concepts based on current knowledge should be effective enough in enhancing students' academic achievement. For the conceptual framework and paradigm, through the collection of data to develop the module, the self-learning digital module undergoes validation of the material by the experts by using the following factors, which consists of content, design or format, technical or technological, and pedagogical. Okay. Okay, now for the research problem. The study sought to answer the following question. Number 1, how may the self-learning digital module in Mathematics 9 be developed? And for number 2, how may the validation of self-learning digital module, considering the level of acceptability from the experts, be described in terms of the following factors: content, design and format, technical or technological, and pedagogical. Now, for the methods. To attain this research objective, the following research methods are utilized. Okay, so the study used research and development design. Research and development in the field of education is a research design used to gather new knowledge, which leads in developing new or improved educational materials that can be used to improve the quality of the students' academic achievement. For the continuation of the methods, the respondents of the study were 17 experts in their field, which were subject matter experts and validators of the proposed self-learning digital module. The experts were identified through purposive sampling. The SME of this study consists of 10 subject matter experts. These are external, non-affiliated grade 9 mathematics teachers from selected public schools in Division of Pampanga, which are experts in the content of Mathematics 9 for 3 years or more. The validators consist of 7 experts in their respective fields, which consists of 1 mathematics coordinator, 3 ICT experts, 2 mathematics teachers, and 1 English critic. Now, for the instrument. The researcher used 3 instruments to conduct the study. First is the evaluation instrument for topics to be included in the D or ODEL module. This serves as the basis and identification for the essential and non-essential learning competencies that was included in the SLDM. These learning competencies was based from the Department of Education's curriculum. Okay, next. The evaluation rating sheet for D and ODEL modules. This was used by the validators to validate the SLDM. It consists of the following factors: the content, design or format, technical or technological, and pedagogical. Each criterion in the following factors were answerable by a yes or no. Both these instruments were adapted from the College of Education of Pampanga State Agricultural University. And the last instrument will be the self-learning digital module, or let's call it as the SLDM. This is a digital material that was developed by the researcher based from the essential learning competencies in Mathematics 9. It is a self-sufficient, self-contained unit of instruction, which was designed in Google Classroom. This is a student-friendly and an open-access learning management system chosen by the researcher. The procedure was divided into 3 phases. The first phase in developing the SLDM was the preparation phase. The researcher asked permission to adopt both instruments through letter, which was addressed to the Dean of College of Education of Pampanga State Agricultural University. The researcher afterwards identified the 2 sets of experts through purposive sampling. These experts were secured consent through another permission of letter, which was addressed this time to the school heads of experts involved. Lastly, the researcher identified all the learning competencies in Mathematics 9 and gathered all the necessary references as a guide in developing the module. So the next phase is the development of the SLDM. Okay, the second phase in developing the SLDM was the development phase. The 10 subject matter experts selected through purposive sampling received a copy of the evaluation instruments for topics supposed to be included in the other module. This is through Google Forms. This was used to determine the essential and non-essential learning competencies in the Mathematics 9 curriculum. The essential learning competencies serve as the basis of the lessons in the proposed SLDM based on the Lush table of minimum values for CBR. After the researcher identified the essential learning competencies, the learner organized each learning competencies based on the nature of topics. The researcher prepared the content, graphics, activities, and assessment of each topics, which was divided into 9 sections. This preparation served as the initial draft of the SLDM. After the development of the SLDM, the module passed through validation to determine its validity and usefulness. 7 experts in the field, which I mentioned earlier, was given an access to the Google Classroom and their own copy of the validation rating for the ODEL modules through Google Form as well to validate the material. The components that were evaluated are the content, design and format, technical and technological, and pedagogical aspects as what I mentioned earlier of the SLDM. Revisions are made based from the suggestion and recommendation of the experts, and until all the criterion in each factors are all marked yes, which serve as the final validation. Statistical treatment was used in tallying the nominal data in the initial and final stage of the validation. Let us now proceed to the results and discussion of the study. For research objective number 1, how may the self-learning digital module in Mathematics 9 be developed? This table shows the phases involved in the development of a self-learning digital module in Mathematics 9, namely the preparation phase, development phase, and validation phases. The researcher carefully followed all the steps in each phases, which was discussed in the procedure part of the methods which I already discussed a while ago. This implies that the digital modules was developed through a logical sequence phases, the preparation, development, and validation phase. This is consonant with the study of Verano and Alonso from 2019, in which their developed module underwent the same phases. With this, it is concluded that the self-learning digital module was developed through a learning management system called the Google Classroom based on planning, development, and validation phases. For the second research objective, how may the validation of self-learning digital module, considering the level of acceptability from the experts, be described in terms of content, design and format, technical or technological, and pedagogical? Table 2.1.1 shows the learning competencies on the first quarter in Mathematics 9. Based on the table, 13 out of the 16 learning competencies, or 81.25%, were considered as essential. The results were confirmed based from the results of the content validity ratio, which required minimum value of 0.62 for the topics to be considered as essential, as emphasized in the LOSH content validity ratio, or CVR, with the evaluation of 10 subject experts. Table 2.1.2 highlights the essential and not essential topics in Mathematics 9 for the second quarter. Okay, based on the table, 12 out of 12 learning competencies, or 100% of the learning competencies, were considered as essential. For table 2.1.3, the data presented in this table shows the essential and non-essential topics in Mathematics 9 this time for third quarter. Based on the table, 13 out of 14 learning competencies, or 92.85%, were considered as essential. And lastly, for the last table, which consists of the learning competencies on the fourth quarter, is presented here. It shows the essential and non-essential topics in the fourth quarter, or 6 out of 6, or 100% of the learning competencies are considered essential. Okay, so let us now proceed to the result of the validation of the SLDM. Okay, so table 2.2.1 shows the validation of the SLDM as to content. Notice that the total number of experts are cut into 4. Okay, so ICT experts was excluded in the validation of factor, as well as in the designer format and pedagogy. They only validated the technical or technological factors. These four validators are the mathematics coordinator, two mathematics 9 teachers, and the English critic. Going back to the table, based on the results of the initial validation, all validators, or 4 out of 4, agreed that the SLDM met all the 5 criteria in the factor of content. The module was commended in terms of the sections of each topic, as well as the interactions in each part, as they are presented in this distinct manner, which can help the learner understand each lesson with ease. The result means that the developed SLDM comprise of lessons that are aligned with the learning competencies set by the Department of Education. In Mathematics 9, the information provided in the SLDM are important, useful, and enough. Moreover, the content of the SLDM is presented clearly, accurately, and free from errors. It can also be considered that the developed module is learner-friendly since it can be easily understood by the learners. Table 2.2.2 shows the validation as to design and format of the SLDM. Based on the result of the initial validation, all validators, or 4 out of 4, agreed that the SLDM met the criteria numbers 1, 2, 4, and 5 in the factor of design and format, while only 3 out of 4 validators agreed that the SLDM met the criteria number 3. The validator was not satisfied in the presence of criteria number 3 of the developed module, suggested that the graphics must be engaging, more simple, yet visual. Therefore, it was modified in such a way that the banners and information graphics used in the SLDM will be satisfied by the validator standards in the validator standards. In the final validation, criteria number 3 was already satisfied. Based on the results of the final validation, all validators, or 4 out of 4, agreed that the SLDM met all the criteria in the factor of design format. The result evidently shows that the textual information used in the developed SLDM is presented in a clear and distinct manner. Information graphics used in the SLDM is concise and relevant and can easily catch the students' attention, which will motivate them to learn and answer the content of the module properly. Lastly, the developed SLDM, specifically its topics, subtopics, and discussions, are properly labeled and arranged. For the data presented in 2.2.3, it highlights the validation as to technical aspect. Okay, as what I mentioned a while ago, the ICT experts were only the one who will validate this factor. Based on the result of the initial validation, all validators, or 3 out of 3, agreed that the SLDM met the criteria numbers 2 to 5. Okay, in the factor of technical and technological factors. While only 2 out of 3 validators agreed that the SLDM met the criteria number 1. One of the validators did not agree that the developed SLDM does not require equipment or applications beyond what is typically available to the students. For that reason, the researcher carefully explained the features of Google Classroom to the validator, wherein it can be accessed in any types of operating system, as well as mobile or computer browsers. Upon enlightenment, the validator agreed on the existence of number 1 criterion in the SLDM. Based on the results of final validation, all validators, or 3 out of 3, agreed that the SLDM met all the criteria in the factor of technical or technological. The results denotes that the developed module can be easily accessed by the learner by using the typical available applications they have, just like mobile phones or computers. Moreover, the module can be accessed online, which allows the learner to interact with the teacher and other learners. This is virtually through comments and private messages. And lastly, the SLDM was fully integrated in a learning management system, which is called Google Classroom, which made online distance learning possible. Lastly, the data presented in Table 2.2.4 shows the validation as to pedagogical factor. Based on the result of the initial validation, all validators, or 4 out of 4, agreed that the SLDM met all the criteria in the factor of pedagogy. However, there is one validator who is already satisfied, even though he is already satisfied in this factor. He left a suggestion to consider, including the time, to include the time allotment per topic so that the learner can estimate the time frame they need to answer the module. This was considered by the researcher by adding an enough time frame in each topic. So the result indicates that the objectives of each lesson in the SLDM are well formulated and gives an insight on what the learners expect to learn on that session. Moreover, the learner's prior knowledge is properly assessed. Through what I know section. The title of that section is What I Know. Of each module to bridge the gap between what they already know in the topic and what they must know as they progress in the lesson. In addition, various motivational strategies are embedded in each module to help them gain valued outcomes. Assessment, in which this is the final section of each module. The developed SLDM is in charge in critical and higher order thinking skills of the learners, which is very essential, especially in mathematics. Lastly, tracking their progress and checking of correct answers as a way of feedback to monitor the improvement is evident in the developed SLDM. Based from the result, the researcher concluded that the content of the module were identified and selected by taking into account the essential learning competencies evaluated by the 10 subject matter experts using the Lush content validity ratio, or what you call CVR, and was further validated by 7 experts in terms of content, format and design, technical or technological, and pedagogy, which gained the approval of all the experts based on the DE or other writing sheets they use, which satisfies the self-learning digital module, or SLDM, as a standard learning material in teaching Mathematics 9. Based from this result of the study and conclusions, the researcher recommended that the self-learning digital module can also be considered in different subject areas and courses to motivate the students using the technology in learning. The self-learning digital module can be used as a practical alternative to printed modules. And lastly, further studies are encouraged along this undertaking to enrich the findings in terms of its usage and effectiveness using experimental design. Once again, I am Mr. Jerome Tanglao. Thank you for listening. Have a good day.